Here's the spiral review for spiral 4. We're going to start off with exponentials and logs. First off, we got to deal with this in terms of some kind of an exponential expression. So if we've got log base a of 2 to the a is equal to something, it might make sense if we convert this to exponential to see what's going on. So we get a to the a divided by 4 is equal to 2 to the a, and to be honest, it seems kind of like a dead end. I've got lots of a's in there, and I'm not really sure what to do. So I might hold off on that and maybe come back to that. Since that didn't seem like that was a good beginning, maybe I'll try some log properties. I know I can bring this guy down front. I brought it in front of the if, which is not useful. And that becomes a times log base a of 2 is equal to a over 4. And when I do that, we end up getting somewhere I could divide both sides by a. And in doing that, we should get log base a of 2 is equal to 1/4. Okay, now we're dealing with something that's more useful to us, because a to the 1/4 is going to be 2. In order to get the a by itself, I'm going to raise both sides to a power of 4. So a to the 1/4 to the 4th is equal to 2 to the 4th, and that's going to be 16. For the second one here, we're going to first get the log part by itself. My goal is always to kind of get the weird part of the equation on its own before I do anything else, so minus 2 to both, or minus 5 to both sides. Log base 4 of 4x minus 1 is equal to 2. That's where the 2 came from. I'm going to convert this to exponential form. So 4 squared is equal to 4x minus 1, which means that 17 is equal to 4x, and x is equal to 17 over 4. We should check to make sure that this works. Sometimes log equations end up with things that don't actually work. So 4 times 17 over 4 is 17. 17 minus 1 is 16. Log base 4 of 16 is 2. 2 plus 5 is 7. Woohoo! For number 3, which shows also number 2, which is fun. We've got ln of x minus 2 is less than 0. So I want to talk about this. So ln of x minus 2 is less than 0. I'm going to convert this to a exponential before I do anything else. I know that ln of x is the same as log base e of x. So if we write this as an exponential, we're talking about e to the 0. Ooh, this is going to be fun. How do you convert this and keep it in terms of that inequality? I'm going to rethink this because I don't know how to do that. That's fun. Instead, I'm going to what I call exponentiate both sides. I'm going to raise both sides to a power of e. So e to the ln of x minus 2 has to be less than e to the 0. And I think this is what I was going to end up with anyway, based on how I was trying to set this up. E and ln cancel each other out, so you get x minus 2 is less than, and if e to the 0 is 1, so we're talking about if x is less than 3. This gets a little bit more complicated, because I also know we have a domain issue here. What? A domain issue too? For logs, the inside cannot be less than, or cannot be anything below 0, including 0. So we have to say that x cannot be below 0. In other words, it's got to be greater than 0. That's a much better way to say that. So x has to be greater than 2. When these powers combine, we get x is between 2 and 3, which happens to be c. That's kind of a confusing problem. For part 2, we're dealing with general functions, which basically is composition and stuff. Emphasis on the fun stuff that we can do with that. We might look at m of h of 3. So we've got h of 3, which is going to be -1, m of -1. So m is this, the graph. I'm going to go to -1, and I find that this has a height of 3. My answer is 3. I get a lovely combo thing here. M of h of 1. So we're going to start with h of 1 and h of 1. If I can actually see what's going on, it's going to be 1. That's fun. So I did that. Now I'm going to do m of 1. I'm going to take the answer I got, plug it in. And m of 1 is undefined there, so I'm going to go down to -2. And now I'm going to go to my third level to do h of -2. H is my table, and I get 0 as an answer. And then finally my outside level is going to be m of 0, which in this case has a height of 2. 2 is my final answer. Whew. Then we are going to have f of g of h of m of -1. So I probably should be able to see all of these for this one. I might even just do this off to the side because there's a lot of stuff. Again, I'm going to start on the inside. M of -1. And we already said that's 3 because that's where that point is. Then I'm going to find h of 3. I'm going to take that, plug it in. And h of 3 is -1. That's fun. Then I'm going to go one more step out, and I'm going to find g of -1. And g is going to be -3 x to the third, -3, -1 to the third. -1 to the third is -1. -3 times -1 is 3. And then finally we're going to have f of 3, which is 3 times 3 squared minus 5 times 3. So 27 minus 15 is going to be 12. That was the bell. M inverse of 2. So what this is really asking us to do is to find an x value when y is equal to 2. And if I'm finding m inverse of 2, there are a couple possibilities for that. That could be 0, or it could be 2. Inverses ask us to find that value going backwards. So we've got b of x is equal to this stuff, and find b of 1 and b of 2 if possible. Okay, I'm going to just kind of plug this in. So b of 1 is equal to 3f, and 1 minus 1 is 0, so 3f of 0, minus 2m of 1. Alright, I'm going to rewrite that so it actually looks like an f instead of a plus. F of 0, 3 times 0 minus 0 is going to be 0, so that's going to be 0. Okay, and m of 1 is going to be -4, minus 2 times -2. Wow, I just did that again in my head. 2 times -2 is going to be 4. 0 minus 4 is going to be -4. And then finally, we're doing the same thing, but for 2. So b of 2, let's do this in black pen. And that's going to be equal to 3 times f 2 minus 1 is 1. And then minus 2m of 2. I could just... Oh, good, I'm crossing things out, which is not what I want to do. This is kind of a mess today. Oh, good, I can still see that. Okay, 3f of 1 That's going to be 3 minus 5 is going to be negative 2 times 6. I'm saying the answers instead of the questions again and again today. This is fun. And then I've got minus 2m of 2. M of 2 is 2, so that's going to be 2 times 2. Minus 4 is negative 10. Zoom out so we can see everything on one page when I PDF it. And we're good to go. Next up, we got some limits. The first part of this is going to be a little bit more limit-like. The next part is going to be dealing more with continuity-style questions. First question up, we got limit at infinity. And the big idea here is kind of seeing which side wins as n gets really big. The big idea, I said that twice, if n's getting really big, both the top and the bottom are squared as far as that variable. So they're about equal on the scale of which one's getting bigger faster. Because of that, we can just look at the ratio of their values and we get 4 as our answer. In terms of what this means algebraically, if you really wanted to dive into this, you could, and you don't have to do this. So as n approaches infinity, what I'm going to do is factor in n squared out of the top and bottom of this. So we get n squared times 4. And in the bottom, we're going to have n squared times 1 plus, it's going to be 10,000 over n. You might notice that the n squareds cancel out. And if I plug infinity in, which again we can't really do, 10,000 divided by infinity is basically 0, leaving us with 4 over 1. That's the algebra reason for why that works. Given this graph, determine the requested limits. Ooh, that sounds fun. Okay, the limit is x approaches 0 from the left. So we're coming in from the left, we have a value of 0. The limit is x approaches 0 from the right. We're coming from the right, we have a value of 2. As x approaches 0 overall, because it's different from both sides, that limit does not exist. And the limit is x approaches 3 from the left and from the right. Both of them get to the same value, and we get 5 as a height there. That's it for limits. For limits in continuity, which is our new section, we've got a function which is defined up above, and we've got to find a value of k to make this continuous at x equals 2. I need to know that continuity means that I need the limit as x approaches 2 from the left of f of x, and because this is the left side, I'm going to use 3x as my equation, and that's going to be 6. I need the limit as x approaches 2 from the right, because this is the right side of my graph, because it's the greater than side. I'm going to use the kx squared thing, so kx squared minus 6. And when I plug this in, we get, well, k times 2 squared is k times 4, or 4k, minus 6. And finally, you do need to say that f of 2 is equal to this limit. But for this to exist, the whole thing has to be equal to each piece. So the limit has to exist, and for that to be true, the two limits that we just found must be equal. So 6 must be equal to 4k minus 6. We're going to add 6 to both sides. We get 12, and that means that k is going to be 3. And then finally on to number 9. So given the graph at the right, we're looking at things that are correct. So the limit is x approaches negative 2 from the right. It's going to have a height of negative 3. Okay, so that one's okay, so that exists. The limit is x approaches negative 2 from the left. Alright, so that approaches a point, we're okay. There will be times that one-side limits don't exist, but we're not going to really worry about those this year. If you're curious, I'm happy to talk to you about that, but otherwise we don't need to worry about that. That has a height of 4. That one exists, so both A and However, that does mean for the second part of this, so the limit as x approaches -2, because I get a different answer from each side, the overall limit does not exist. Therefore, B is not true. If I'm thinking about f being defined, so for a point to be defined, we can't have open circles. If there was a filled-in circle somewhere, that would be cool. That point would be defined, but there's not. We just have open circles there, so there is no value for f of -2. So this one is also not true. And for f to be continuous, we need three things. We need the limit from the left and right, and I'm going to shorten that just to say the limit as x approaches 2. And that must equal f of -2. And here we have kind of this double thing going on. There's the bell again. Because this point does not exist, and because this limit does not exist, this cannot possibly be continuous.